So not all data is normal. And in fact, there's differing degrees of normality. You can have some data that's approximately normal. You can have some data that is very normal. So we want to be able to assess how normal our data set is. So in this section, we're looking at descriptive methods for assessing normality. So our inference in the later chapters, it requires our population, a lot of it, to be approximately normal. So we want to know, how do we check for that? Well, first thing we do is construct a histogram or a stem and leaf plot and check and see if it's symmetric or mound-shaped. That's one possibility. You could also do a box plot. You could compute your intervals, x bar plus or minus 1, 2, and 3 standard deviations, and see if they correspond to the 68%, 95, and almost 100% that go with the empirical rule. Another quick check is you can look at the IQR and then divide it by the sample standard deviation. If that's close to 1.3, data will be approximately normal. And then probably the best method is to construct a normal probability plot, also called a QQ plot. So if your QQ plot is approximately linear, then your data is going to be approximately normal. So let's look back at some earlier data here with these cough improvement scores using honey as a cough method. So I want to assess the entire set of data for normality here. So I did a histogram and a box plot. And we can see, that this histogram, it is not bell-shaped. I mean, it's kind of got two areas of concentration here, but it doesn't have any extreme outliers. But it is bimodal, so it's not symmetric. But we don't have any extreme outliers, at least. So it doesn't look like we have any extreme outliers. Because there's a little gap in the data, but there's not big gaps in the data. Now if we look at the box plot here, we see the mean is in the middle of the box, or I'm sorry, the median in the middle of the box here. And remember, this is Q1 and Q3. And then these are the largest and smallest values that are not outliers. So we're seeing no outliers errors, no asterisks or zeros. So we're seeing that the median here is approximately mid-box. So that's indicating symmetric, fairly symmetric. We do see the left whisker is longer here, indicating a little bit of skewing, longer than the right whisker. But what we're seeing overall here, fairly symmetric from the box plot. So that's just a different picture of the data. So, and this is not an exact science. Statistics is not an exact science. So you can assess multiple measures of normality and try and make a decision about whether normality is good enough for your circumstances. Here is the summary data. We had 64 measurements total. Our mean was 8.5. Variance 12.1, standard deviation 3.49. Median 9, range 14, got min and max, Q1, Q3. So second possibility is we can measure how many data values are within 1, 2, and 3 standard deviations. So our X bar here was about 8.51. And then we could add and subtract, plus or minus 1 standard deviation, be about 3.49. So that gives us a range here of 5.02 to 12. And then if you just go back and count up how many pieces of data are between 5 and 12, it's actually 48. So this actually contains 48 out of the 64 pieces of data, which is 0.75. or 75%. And then if you look at plus or minus 2 standard deviations, that actually contains all of the data, 100%, and then 3 standard deviations, again, 100%. So remember, for the empirical rule for bell-shaped data, this should be about 68%, 95%, and almost 100%. So we're seeing that those are not too far off. Could be closer, but not too far off. So that's telling us approximately normal. IQR divided by S. So our Q3 minus Q1, 12 minus 6. Our standard deviation, 3.49. And when we divide that out, we get 1.72. Oops, 1.72, and that is not approximately 1.3. So by that measure, so up here we're seeing approximately normal. By this measure, this is saying that we are not approximately normal. That's a fair amount off from 1.3. And then the normal probability plot. So this is plotting the normal quantile, which is the z-score, versus the x itself. So this is z-score here versus x, z versus x. And we see that data not exactly linear, but it's got a correlation coefficient of 0.977, which is really close to 1. So this is telling us here that this is approximately 1. So that's telling us data is approximately normal. Now, a lot of these things you can do with calculator. You cannot do the normal probability plot with calculator, but I linked an Excel sheet that you can use to do that. So this is our normality check or outlier analysis. And you just enter your sample data here in the middle. So I entered that, and then you press go. And then we scroll over here, and here is it computes our quartiles for us, IQR, lower and upper fences, correlation coefficient from the plot, 9867. And here actually is our normality plot. And you're seeing that those are pretty close to a straight line. Now this one plotted the z-scores on the vertical and data values on the horizontal. Okay for t-test here, so it's telling you that's a true. So it's looking at normal probability plot and then comparing that against the standard to see if that's going to give good results for t-test is hypothesis test. So, and then nearly normal, it assesses that as true. And then it also does D'Agostino-Pearson test, and that one also comes out as nearly normal. So you got these Ryan-Joyner and then the Pearson test, and both of those are saying approximately normal. It's coming out true for t-tests. This data is approximately normal. So it's good enough for us. So again, number 4, the normality plot or the QQ plot, if you can do that, that's going to be your authoritative of whether your data is normal enough. If you don't have access to normality plot, then you can look at some of these other measures. But that's the most important one.